There is a world in our solar system that is literally being torn apart from the inside out. Every single second of every day, its surface is ripping open. Fountains of molten rock are shooting hundreds of miles into space, and the ground beneath your feet would literally be moving in waves, like an ocean, except made of solid rock. This is not a planet from a science fiction movie. This is not a distant exoplanet we barely understand. This is a moon orbiting Jupiter, and it is the single most geologically violent place ever discovered in the entire known universe. Its name is Io, and once you learn what is actually happening on its surface, you will never look at the night sky the same way again. Let's start with a number that will immediately break your brain. 400. That is how many active volcanoes exist on Io right now, at this very moment. Not dormant, not extinct, active, erupting. 400 of them simultaneously tearing through the crust and pumping material into space. For comparison, Earth, our entire planet, has roughly 1,500 volcanoes total, and only about 40 to 50 of those are erupting in any given year. Io, a moon smaller than our own, has 10 times that number going off at the same time, non-stop, without pause, without rest, without mercy. But here's what makes this truly insane. Io should not exist the way it does. By every rule of planetary science, a moon this size, this far from the sun, should be a frozen, dead rock. It should be cold. It should be quiet. It should be boring. Instead, it is the most volcanically active body in the entire solar system. And the reason why is one of the most mind-bending stories in all of science. Let me ask you something. Have you ever squeezed a stress ball repeatedly, over and over, really fast? After a while, it heats up. The friction, the compression, the constant deformation of the material generates heat. Now imagine that happening to an entire world. Imagine the gravity of Jupiter, the largest planet in our solar system, a gas giant so massive that 1,300 Earths could fit inside it. Imagine that gravity pulling on Io with such force that the moon itself is physically squeezed and stretched millions of times. Not metaphorically, literally. The solid rock of Io flexes, it bends, it deforms, and all of that mechanical energy converts into heat. Staggering, catastrophic, world-melting heat. This process is called tidal heating, and on Io, it operates at a scale that is almost impossible to comprehend. The heat generated inside Io is so intense that the moon loses approximately 100 billion watts of energy per second through its volcanic activity. That is roughly the equivalent of the entire power output of human civilization, just bleeding out of one moon into space, every single second. And it never stops, because Jupiter never stops pulling. Now here's the hook that should keep you absolutely glued to this video. Scientists recently discovered something about Io that completely overturned what we thought we knew about how volcanoes work on this moon. Something that suggests the interior of Io might be structured in a way we never anticipated. Something that raises a question about whether there could be, under all that fire, under all that sulfur, under all those eruptions, something that resembles a liquid ocean, not of water, of rock, of pure planet-wide magma. We are going to take you inside Io. We are going to walk you through what it would actually look like to stand on that surface, what you would see, what you would feel, and why you would survive for approximately 0 seconds without protection. We are going to explain the gravitational war that Io is caught in between Jupiter and its neighboring moons, and we are going to show you why Io is not just a geological freak, it's a window into the early history of Earth itself, and possibly the key to understanding how life-bearing planets are born. Stay with us, because by the end of this video, you will understand that the most extreme place in our solar system is not some distant, mysterious object at the edge of everything. It's been right there, orbiting Jupiter, visible through a backyard telescope this entire time. We just didn't know how insane it truly was. This is Io, and we are going inside.
Picture the color yellow. Now picture it covering an entire world. From space, Io looks like a giant pizza, and astronomers have actually called it that. Its surface is painted in shades of yellow, orange, red, white, and black, all of it deposited by continuous volcanic eruptions that coat the ground in sulfur compounds. There is almost no impact craters on Io. None. On every other solid body in the solar system, the Moon, Mars, Mercury, the surface is scarred with craters from billions of years of asteroid impacts. Those craters tell us the history of the solar system, like a geological diary. But on Io, that diary has been erased completely. The volcanic resurfacing happens so fast, so relentlessly, that any impact formed by an impact is buried and erased within a geologically tiny span of time. Io renews its own surface faster than anything else we have ever observed. The volcanoes responsible for this are not like anything you have seen on Earth. The largest volcanic structure on Io is called Pele, named for the Hawaiian goddess of volcanoes, and it produces a plume of sulfur dioxide gas and particles that rises 300 kilometers above the surface. 300 kilometers! The International Space Station orbits Earth at roughly 400 kilometers altitude. Pele's eruption plume nearly reaches the height of a space station orbit, and it deposits material across an area larger than the entire continental United States in a ring of red sulfur around the vent. But Pele isn't even close to the most powerful eruption ever recorded on Io. In 2001, astronomers using the Keck Observatory captured images of an eruption called SURT, and what they saw defied comprehension. In a matter of days, SURT released more thermal energy than all of Earth's volcanoes combined have released in the past century. In days! The lava temperature measured during some of Io's eruptions exceeds 1,600 degrees Celsius, hotter than any lava measured on Earth in modern times, and suggesting that Io's magma composition may be similar to ancient ultramafic lavas that erupted on our own planet over 3 billion years ago. This brings us to the gravity war. Io orbits Jupiter in almost exactly the same time as Europa, another of Jupiter's moons, takes to complete 2 orbits, and Ganymede to complete 4. This is not a coincidence. It is a gravitational lock called the Laplace resonance, and it is the engine of Io's destruction and creation simultaneously. Every time Io lines up with Europa and Ganymede, their combined gravitational pull tugs on Io from a slightly different angle. Jupiter pulls from one side, the other moons pull from another, and Io, caught in the middle, gets stretched and compressed like cosmic taffy. The tidal flex that results from this gravitational war is enormous. Io's surface rises and falls by up to 100 meters with every single orbit. 100 meters! Imagine the ground beneath your city rising and falling the height of a 30-story building every 42 hours, continuously, forever. The rock doesn't just move, it heats up. The friction from all that flexing melts rock from the inside, and that molten material has to go somewhere. It goes up, through fissures, through volcanic vents, through lava lakes that cover areas the size of small countries. The largest known lava lake on Io is called Loki Patera, It's roughly 200 kilometers across, larger than the entire state of West Virginia, and it's not just a passive pool of sitting lava. Loki Patera appears to overturn itself in a clockwise rotation about 500 days as waves of fresh hot lava well up from below and the cooling crust on the surface sinks back down. Scientists have compared it to a conveyor belt of planetary proportions, constantly cycling new material up from the interior and pulling old crust back down. It is the largest active volcanic feature in the entire solar system, and it is operating continuously right now as you watch this video. Now, here's where it gets even more disturbing. New data from the Juno spacecraft, which has been making close flybys of Io since 2023, has revealed something unexpected about the interior structure of this moon. For years, the dominant theory was that Io had a partially molten layer beneath its crust, a mushy zone of rock and magma mixed together, and that this was the source of all the volcanic activity. But Juno's measurements of Io's magnetic and gravitational field are now suggesting a different picture, one where the interior might contain a much larger, more coherent global magmatic ocean. Not patches of melted rock, a worldwide ocean of liquid silicate rock sitting beneath the crust, kilometers deep, wrapping the entire interior of the moon. If confirmed, this would make Io the only body in the solar system besides Earth known to have a global magmatic ocean, and it would fundamentally change how we model volcanic worlds. And here's the real question no one is saying out loud. If Io has a global magmatic ocean, what is sitting at the boundary between that ocean and the base of the crust above it? What chemistry is happening there? What elements are being cycled? Because here on Earth, the interface between our mantle and crust is where some of the most critical geological processes take place, processes that have, over billions of years, made our planet habitable. The comparison is uncomfortable and fascinating.
Let's do something different. Let's actually go there. Not with a spacecraft, with imagination. Because the reality of standing on Io is so extreme, so viscerally alien, that it deserves to be experienced in full. You land. The first thing you notice is that the ground is not gray or brown like the moon. It is yellow, a pale sulfurous yellow that extends in all directions. The sky above you is black. Io has virtually no atmosphere to speak of, just a thin, shifting haze of sulfur dioxide gas that hugs the surface near active vents. There is no breathable air. There is no warmth from the sun. Io is 5 times farther from the sun than Earth, and sunlight here is roughly 27 times weaker. You are in a spacesuit, obviously. Good thing, because what comes next would kill you in seconds without it. You look to your left, and 50 kilometers away, a mountain rises from the surface. Not a volcanic cone. Io's mountains are not primarily volcanic in origin, which is one of its strangest features. They are thrust mountains, created when the constant addition of new volcanic material on the surface compresses and buckles the crust beneath, forcing massive blocks of rock upward. Some of Io's mountains are taller than Mount Everest. Boa Sole Mountains reaches 18 kilometers in height, more than twice the height of Everest. They loom over the surface like broken teeth on a planet that never heals. The ground shifts beneath your boots, not violently, subtly, but you can measure it. The tidal flexing is constant, the rock breathing in and out on a 42-hour cycle. Every step you take is on a surface that is fundamentally, continuously unstable. Then you see it. To the north, a plume, a column of material, sulfur dioxide gas, fine sulfur particles, entrained lava droplets, shooting straight up from the surface into the void.
It does not arc like a geyser. It goes up, ballistically, into the black sky, reaching heights that would place it in low Earth orbit before the particles fall back down over hundreds of kilometers in a slow, ghostly rain of sulfur. The silence is absolute because there is no air to carry sound. You are watching the largest active geological feature in the solar system in complete, perfect silence. It is the most terrifying, beautiful thing imaginable. Beneath your feet, kilometers down, the magma ocean churns. Heat moves upward in convective plumes, columns of hotter rock rising, cooler rock sinking, in a planet-wide circulation that has been running without pause for billions of years, since before the dinosaurs, since before the first complex life on Earth. Io has been burning this entire time. And this is where the story becomes genuinely profound. Because Io is not just a freak of nature, it is a time machine. The volcanic processes happening on Io right now, the ultramafic lavas, the tidal heating, the rapid crustal recycling, these are believed to mirror the processes that dominated early Earth. Our planet, roughly 4 billion years ago, was an Io-like world, volcanic, brutal, surfaced with magma, constantly renewing itself. The same geological violence that makes Io so extreme is precisely what made early Earth so fertile. It recycled elements, vented gases that formed our early atmosphere, and created the chemical diversity that eventually gave rise to life. When scientists study Io, they are not just studying Io, they are looking at our own past. They are studying the conditions that had to exist for a planet to eventually become habitable. And this is why there is a quiet, persistent conversation happening in planetary science right now about whether Io, with its extreme chemistry, its volcanic outgassing, its possible global magma ocean, could harbor any form of life. Not on the surface, which is obviously completely uninhabitable, but deep within the interface between rock layers, in the microenvironments created by hydrothermal venting beneath the surface. Life on Earth was found at hydrothermal vents in the deep ocean, in conditions once thought to be completely inhospitable. The question of whether similar extremophile life could exist within Io is a legitimate scientific question being taken seriously right now. And there is one more thing, one more discovery that no one is talking about enough. Juno recently detected signs of electromagnetic activity above Io's surface, consistent with lightning, on a moon with almost no atmosphere. Lightning generated not by weather, but by the interaction between volcanic plumes and Jupiter's intense magnetosphere. Io sits inside Jupiter's radiation belts, bombarded continuously by high-energy particles that would deliver a lethal radiation dose to a human in about 10 minutes. That radiation interacts with the volcanic gases, creates bizarre atmospheric chemistry, and generates electrical phenomena that we are still just beginning to understand. Io is not just geologically insane, it is electrically insane, chemically insane. It is a moon that breaks every quiet assumption we make about what a moon is supposed to be.
Here is what we know. Io is the most geologically active body in the solar system. It has over 400 active volcanoes erupting simultaneously. Its surface is resurfaced so quickly that no impact craters survive. It has lava lakes larger than entire states, mountains taller than Everest, raised not by volcanism, but by the crushing pressure of constant resurfacing. Plumes that reach the altitude of space stations. A tidal heating mechanism so powerful it generates more energy than our entire global civilization. A possible global magma ocean beneath the surface. and lightning arcing through volcanic plumes bathed in lethal Jupiter radiation. All of this on one moon, smaller than our own moon, right there in the night sky. But what we want to leave you with is not the spectacle. The spectacle is obvious. It is breathtaking and overwhelming, and we hope this video has made you feel even a fraction of the awe that scientists feel every time new data arrives from the Juno spacecraft. What we want to leave you with is the meaning. Io tells us that the universe is not a quiet place, that even in our own backyard, not in some distant galaxy, not billions of light years away, but right here in our own solar system, there are places operating at a scale and intensity that should remind us how small and how young our understanding of things truly is. We have been watching Io through telescopes since Galileo first spotted it in 1610. For over 400 years, it was just a point of light. And now, armed with spacecraft and spectrometers and gravitational sensors, we are only just beginning to understand what that point of light actually is. There are missions being planned right now specifically to study Io in greater detail. The ESA's JUICE mission and NASA's Europa Clipper will provide additional flybys and data. There are proposals for an Io volcano observer, a dedicated spacecraft that would orbit Io directly, in the radiation, watching the volcanoes in real time, mapping the magma ocean, sampling the volcanic plumes. If that mission ever launches and returns its data, it will almost certainly rewrite the textbooks on planetary geology again. And here is the last thing to hold on to. If Io, a moon we have known about for 400 years and explored for only a few decades, can still be hiding secrets this profound, this unexpected, this world-altering in their implications, then imagine what is waiting for us everywhere else. Europa, with its global liquid water ocean beneath an ice shell, may harbor life right now. Titan, with its methane lakes and organic chemistry, is a laboratory for prebiotic chemistry. Enceladus is actively venting water ice from a subsurface ocean into space. Our solar system is not a collection of dead rocks around a star. It is a collection of worlds, each one stranger and richer and more alive than the last time we looked. Io is the most geologically insane moon ever discovered. But given how much we are still learning, it may not hold that title for long. If this video made you see our solar system differently, if the thought of a moon with 400 active volcanoes and a possible global magma ocean doing something to your brain, then please hit that subscribe button right now, because we're just getting started. Every week, we go deeper into the most extreme, most beautiful, most mind-bending places in the universe. And the next video in this series is going to make what you just watched feel calm by comparison. Drop a comment below. Tell us, if you could land anywhere in the solar system, knowing you'd be completely safe, would you stand on Io and watch those volcanic plumes shoot into the black sky? Or is there somewhere else calling you? We read every single comment, and your answer might decide what we cover next. The universe is insane, and we're just getting started.